Okay, so I'm going to show you some strategies today that you can use on the next class when we take your test. So if you have multiple choice questions with the systems, you don't always have to do all of the work that we did with everything else. So on question number 1, we're given a graph, and the graph has an intersection point. This point where they intersect, that is the solution to the system. We need to figure out that xy coordinate so we can plug in the x and y values to our answer choices to see which one works. The problem is that's not a very nice point. So what we're going to do is we're going to pick the closest point. The closest x value to that system, to the intersection, is -3. The closest y value is 1. So if I use -3 for x and 1 for y, I should get really close to one of the answers. So let's write that here, -3 and 1, x, y. All right, so in order to test answer choice F, I'm going to rewrite. So F, instead of y, I'm going to use 1 equals negative. Instead of x, I have -3 minus 4. Negative times -3 is 3, so I have 1 equals 3 minus 4. 1 equals -1. That's pretty close. In order to try the second one, I have 1 equals 2 times -3 minus 2. So I'm just checking both equations and answer F. So 2 times -3 is -6 minus 2. 1 equals -8. Okay, now we're going to try G. In order to try G, I'm going to rewrite G's equations. So instead of y, I have 1 equals -3 plus 4. 1 equals 3 plus 4, so 1 equals 7. The other equation is y equals, so 1 equals 2 times -3 minus 4. So 1 equals -6 minus 4. 1 equals -10. Okay, those answers are pretty far from what I needed. All right, so now let's try H. Answer choice H. 1 equals -3 minus 4. 1 equals -7. The second equation, 1 equals -2 times -3 minus 2. So 1 equals 6 minus 2, 4. So 1 equals 4 and 1 equals -7. All right, last answer choice, J. 1 equals -3 plus 4. So 1 equals 1. And then 1 equals -2 times -3 minus 4. So 1 equals 6 minus 4. 1 equals 2. When we plugged in x and y, and we substituted x and y with what we thought was the closest to the ordered pair, the intersection we could get, the only ones that are closest to being true is J. 1, yes, is equal to 1, and 1 is close to equaling 2. The rest are very spread apart. 1 is not anywhere close to equaling to 4 or -8. So because these are true, that's why that's the answer. So now you're going to see a couple questions for you to try on your own and select the answer. Use this method. Figure out where the intersection is, plug in that x and y value. Okay? Try those. Okay, so now we're going to look at question 2. There are 15 plates in a kitchen cabinet. The diameter of each plate is either 7 inches or 12 inches. The diameter of all 15 plates combined is 140 inches. Which system of equations can be used to find the exact number of 7-inch plates, x, and the number of 12-inch plates, y, that are in the cabinet? The first thing we need to do if we have a word problem is write down the variables. So I want you to rewrite that x is the number of 7-inch plates. And y is the number of 12-inch plates. Now we're going to highlight our different scenarios. If I know there are 15 plates, that's going to give me one equation. And that one equation is that x plus y is 15 total. With your other highlighter, we know that each plate is 7 inches or 12 inches, and they're 140. So this isn't going to go in, but total 140 will. So I need equals 140, but I need to be very careful. I know I'm going to add the diameter of the x's and the y's, but you need to look back up here to see that x is 7 inches, so 7 for every x and 12 for every y. That's your system. So I need, the answer is C. Okay, now you're going to do some word problems. Use your highlighters. Well, it'll be on the screen, but think about using your highlighters and select the right answer. Be very careful that you look at them closely to see the variables, okay? You try those. Okay, so back to your notes, question number 3. If you have a table and then the equations are your answer choices, we know that the solution to a system in the table is the point that the table has the same. But if you notice, these two tables don't have any of the same points. So I can't just look for what's the same. So what I'm going to do is I'm going to test each of them. The first table should work for the top equation. So we're going to test the first table in the top equation. We're going to test the second table in the bottom equation. So you're just going to pick a point from each table to test. So if I'm going to test the first one, I'm going to pick to use 9 for x and 0 for y. So number 1, I have 21. Instead of x, I have negative 9. Minus y, instead of y, I have 0. That should equal 9. That 21 times negative 9 minus 0 does not equal 9. So I know that does not work. So I'll try the next one. 3 times negative 9 minus 0 equals negative 27. 3 times negative 9 is negative 27. Minus 0 is negative 27. That does work. So we're good with G. G is still an option. H, 21 times negative 9 minus 0 is not equal to 9. H is out. J, 9 times negative 9 minus 0 equals negative 27. 9 times negative 9 is negative 81, so that doesn't work either. So the only answer choice that worked is G. Now, just to be sure, we're going to take our other table and we're going to input a point from there. So let's say x is 0, y is 8. So if I have x is 0 plus 2 times y is 8 equals 16. 2 times 8 is 16. So because that worked for both equations, that's how we know G is the answer. So you're going to try some examples now with tables. Pick a point to plug into the equation, see which is true. All right, back to your notes, example number 4. Excuse me. Example number 4 says the line graphed on the grid represents the first two equations in a system of linear equations. So that is one of the lines. The other equation, the other line, is going to pass through the points negative 12, 20 and 4, 12. Well, before we can see which statement is true, we need to plot those points. So if x is negative 12 and y is 20, that is this point here. If x is 4 and y is 12, that is this point here. Now, if you connect those 2 points, we end up with a line that looks like that. The solution to this system is where your 2 points touch. But these points, it's where your 2 lines touch, but these 2 lines will never touch each other. So we say the answer is C, no solution. On your page of notes, I want you to write down, if there's no solution, that means they're parallel, right? So I want you to write parallel means the 2 lines have the same rate of change. Because there's one that you're about to do yourself that instead of giving you the 2 points, just tells you the rate at which the two lines change. And if they're the same, then you will have no solution. Okay, so you try some about parallel lines. All right, question number 5. A college student completed some courses worth 3 credits and some courses worth 4 credits. The student earned a total of 59 credits after completing 18 courses. How many courses worth 3 credits did the student complete? So first, I'm going to say I have X is going to be the number of 3 credit courses. Y is the number of 4 credit courses. I'm going to grab a highlighter and I'm going to highlight. Okay, there's 2 totals in this. The first total I see is 59 credits. That needs to go in the same equation with the 3 and the 4 credits. So our first equation is that 3 for every X plus 4 for every Y is 59 total credits. The second equation is going to come from the second total. Second total says that there is 18 courses. So I'm going to say that all of my X courses plus all my Y courses is 18 total. Now this is the kind like we did the other day where we can build a table instead of having to use elimination to solve. Yes, technically you could still use elimination, but the table is a little bit easier. So if you build a table, I need to know the number of X courses, the number of Y courses, then I need to know the total credits. Okay, now we want to know how many 3 credit courses. So I want you to highlight that your answer is going to be found 3 credits would made X. So whatever the X you found that works, that's what the answer will be. Okay, so you start off. If he had 0 3 credit courses, he would have to have 18 of the other. But that's not going to give us 59 total credit hours, so that's not the answer. He could have 1 and 17, 2 and 16, 3 and 15. And then you could keep going. When you keep going down that road, you would find that the answer is 13. Because if he had 13 3 credits, he would have to have 5 4 credits. So if he had 13, then we're going to have 3 times 13 of those plus 5, times plus 4 times 5 of those is 59. So that would work. Okay? So now go try questions like that. All right, last question. What is the value of X in the solution to the system? Technically, you could take this system given to you in question 6 and you could solve using substitution. But the strategy would be that if these are the X values, then you should be able to take these answer choices and plug them into X in both equations. So if we're going to test answer choice A, we're going to take 3 instead of X, negative 6.5, minus 5Y equals 22, and Y equals negative 5 times negative 6.5 plus 32. Then you're going to solve each of these equations for Y. If you get the same answer, then that is correct. That is the right answer of the question. If you get not the same answer, then that is not correct. So if you solve those, 3 times negative 6.5 is hang on, I'm working fast. Let me get a calculator just to make sure. 3 times negative 6.5 is negative 19.5 minus 5y equals 22. Add 19.5. Negative 5y equals hang on. 41.5 divided by negative 5. Y equals negative 8.3. Okay, now when we work the second one, we have negative 5 times negative 6.5 plus 32 is going to give us y equals negative 0.5. Oh, that's wrong. That's wrong. Sorry. $64.5. Y equals 64.5. Okay, but these two answers for y are not equal. So A is not the answer. So then you would try B, and if B didn't work, you try C. If C didn't work, you try D. I know that the answer is C. So let's go ahead and prove that the answer is C, and then you can do the other ones on your own. So if I test C, I know that, so 3, so I'm going to copy the top equation. Instead of x, I'm going to use 6.5 minus 5 instead of y. I don't know y, so I'm leaving y as y. Equals 22. And I know that y equals negative 5 times 6.5 plus 32. All right. 3 times 6.5 is 19.5 minus 5y equals 22. We're going to minus 19.5 this time. So I have negative 5y equals 22 minus 19.5. Is 2.5. And divide by negative 5. Y equals negative 0.5. Okay, now on this side, I do that whole thing. So negative 5 times 6.5 plus 32. And I get y equals negative 0.5. So because I got the same answer out, that's how come we know C is the correct answer. So you would try A. If it didn't work, try B, try C, or just guess around and see if you know. But the whole point is if you know the x value, then you can substitute it in and see which value gave you the same output for y. These didn't match and these did. Got it? So now you're going to practice that and then you're finished.